Hello again, and thank you for watching. In this video I'm showing how to wire up equipment in my shop. I'm running power to my new lift, which takes 220 volts. Adding a 220 volt outlet for my welder, and a 110 volt GFCI outlet, all off the same set of breakers. So let's get started. But first, let's discuss how electricity comes into your panel. You probably have a pole out in front of your house that has a transformer. Inside is two inductive coils wrapped around a core. On one side, you have voltage coming in from the road. This will vary depending on where you are, but let's just say it's a lot, typically over 1,000 volts. The transfer coils are set up to drop the line voltage down to around 230 volts. Now, if this is new to you, you may be thinking, aren't most of my outlets around 110 volts? Where does this come from? Let's add a leg to the middle of the coil. Now, if you measure the voltage to one of the ends of the coil, you'll get half the voltage, or about 115 volts. And the same conveniently works for the other end of the coil. Because this leg can be used with either end of the coil, it is referred to as the common. And often you'll hear electricians refer to the ends of the coil as the hot wires. So now, let's take a look at what this looks like in real space. In a breaker panel, this copper bus is connected to one of the hot ends of the coil, and the other bus is connected to the other end of the coil. When breakers are installed, you'll notice they alternate between the two buses. This is how a 220 volt breaker functions by pulling each of the two hot legs. There is a terminal strip somewhere in the panel that is connected to the common leg. There are one or more ground terminal strips. These connect to an 8-foot copper or aluminum rod in the ground outside. If something goes wrong, say the insulation on a wire is broken in a tool you're using, this will let the electric potential go out to the ground instead of through you. And it's important to understand the difference between ground and common. I've heard of people mixing them up before, so make sure you understand the difference. My lift requires a 20 amp breaker. You will always need to size your wire to handle the amperage your breaker protects to. So in this case, I will be using 12 gauge wire. I'll be running 4 wires. You can look up a conduit fill chart to see what size is needed. For this circuit, 1/2 inch EMT will work fine. I'm no expert at running conduit, so I'll gloss over most of this. You probably also notice I'm not the most comfortable on a ladder. Anything more than a thick pair of socks is high enough for me. I'm installing a handy box right after I pull to the ceiling. This will make it a lot easier to pull wires up through the bends of the conduit. Don't be afraid to add a few of these along the way if necessary. They're pretty inexpensive. Now we can get the wire ready to pull. I don't think there are specific rules, but generally, black insulated wires are used for the hot leg, white insulation is used for the common, and green or bare wire is used for ground. Since this will be a 220 volt circuit, I want to pull 2 black wires. So I'll need to draw out the approximate length off the spool first. When you're in the breaker panel, you'll need to cut the power, so make sure you have enough time to rely on some natural daylight. Use a voltmeter to verify the buses do not have voltage. Don't take any chances and get yourself killed. You're seeing me struggle because my meter needed new batteries and I forgot to record after I changed them. With the power cut off, run a fish tape from the handy box down to the panel. I looped my black wires on the fish tape, then used electrical tape to secure the common and the ground wires to that. Don't be shy with the tape, you need to hold together while you're pulling. Now, make sure nothing gets tangled and start pulling the bundle of wires up. Yep, still not comfortable on the ladder. Laugh at me if you want. I can wrap up my work in the panel before going further. First, install a breaker. This is a 20 amp 220 volt breaker, which is just 2 regular breakers tied together. You can see it grabs a leg off both buses. Tie the 2 black wires to the 2 terminals in the breaker. These will be considered the hot wires from now on. I'm also running a 110 volt outlet, so I'm going to pull over a common. Tie the white wire to the common terminal strip. And finally, tie the green wire to the ground terminal. Lockout plates for the new breaker and fill out the label. Leave the new breaker off and you can return power to the panel. This will let me turn my lights back on. With some better lighting, I can pull the rest of my wire to the end. Pretty simple outside of just straightening out some tangles. Install a cover over the handy box. It's against code to have any exposed wires. Now, I just had to wait several months for the lift to be installed. During the install, we temporarily wired the lift with wire nuts, but for obvious reasons, it can't stay this way. I decided to use soft conduit to run between my ceiling and the lift. Not sure it's the best choice or not. Let me know in the comments what you think. I drilled and tapped holes in the top of my lift to mount another handy box. I started to use fish tape, but found on this short of a run it was just easier to push the wire through the conduit.
Digitize them and everything. So every now and then I'll just get a random picture.
I think my big problem was I declared at some point I'm not taking any photos of me, of myself, or anyone else until either I don't have zits or there's cameras on my phone. So I waited.
Yeah. And apparently nobody ever took me pictures. Good morning. I'm Hot Wings with a hot take. Oh, hot, 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 hot. Scientists stop working on diseases and finally develop road paint you can see in the dark rains.
The bolts to mount the next box were too long and it would interfere with the lift, so I needed to shorten them up. I mounted a 4x4 box next. This will have a cover that will hold the 220 volt outlet. I mounted another 4x4 below for the 110 volt outlet. I removed a knockout on the side of the box to pull in the cable for the hydraulic motor. I used a cable clamp fitting to hold the wire secure. Don't just pull the wires through a sharp hole. common wire isn't used for the 220 volt plug or the lift motor, so it will just drop down to the next box. Take some of the green wire you cut off and run it down to the next box too. Since the next box is only going to be 110 volts, only one black wire needs to be run. I'm going to use the terminals on the 220 volt plug as junctions. So in the ground terminal, I will attach the ground from the panel, the ground to the lower box, and the ground from the lift. For the first of the hot terminals on the plug, attach the hot coming in from the panel and one of the leads from the lift. On the other hot terminal, attach the hot from the panel, the other lead from the lift, and the black wire we sent down for the lower box for the 110 volt outlet. And yes, one of the leads from the hydraulic pump is white, but it is 220 volts, so it will connect to either one of my black wires to the panel.
Run with my toxic love. Look how you make me happy.
Remember that the common wire isn't protected by a breaker. So say you run a 110 volt outlet from one leg and another from the other leg. You could potentially double the amp rating for the common, which will burn up the wire. So when you wire multiple voltages like this, always run your 110 volt circuits from the same leg.
I could give you up.
Outlets and switches sometimes come with extra tabs for different mounting, and sometimes it's necessary to break these off.
Run with my toxic love. Look how you make me happy. You take a hold of me. You take a hold of me. You take a hold of me.
A GFCI outlet will detect any differences in amperage between the hot and the common. Essentially, if any electricity starts to go through you instead of the wiring, it will kill the power. It is safer to use and in many states legally required. I bought the cheapest switch on the shelf, not realizing it had screw posts and not clamp terminals. So I had to add fork terminals to the ends of each wire for the switch. There are 4 terminals on a GFCI. 2 are labeled line and 2 are labeled load. Wire your incoming power to the line side. The load terminals are used if you want to run subsequent outlets that will be protected by the GFCI unit. You'll see this in your home kitchen or bathroom. On an outlet, typically there will be a terminal coated a gold color and another plated a silver color. Wire the hot wire to gold and the common to the silver. As you might expect, the green terminal is for ground. And I only need to switch the hot wire. The common comes in and goes straight to the outlet. Go back and make sure there's a cover on all the handy boxes. So if you're wondering why I put a switch on my outlet, the lift is rated for 20 amps. So I have something with a high draw like these halogen lights, and I try and run the lift, I may trip a breaker. Instead of having to unplug devices, I can just quickly turn them off, run the lift, then turn them back on. having a 220 volt outlet next to the lift is a definite must. It's already saved me a few hassles. And that about sums up how to wire up equipment in your shop. If you have any questions, feel free to leave a comment. Otherwise, thank you for watching, and I'll see you next time.